everyone, I'm Professor Harrison, and welcome back to our module on probability for finance. Today we're covering two related topics: the correlation coefficient, which fixes the scale problem we ran into with covariance, and the distinction between correlation and causation, which ends up being one of the most consequential things to get right in any data driven field. We're following Danny, a gambler with a mountain of debt, working his way through a box of mysterious letters addressed to his late father, trying to understand what happened to the family fortune. Today he noticed something in Victor's brokerage statements, a counterparty that shows up again and again, labeled only TRQ. He wants to know whether the pattern is real. He opens up another one of those mysterious letters. In a previous letter, covariance gave you the direction of co-movement between two variables, but the magnitude of the covariance depends on the units and scale of both variables, which means it can't tell you whether a relationship is strong or weak in any absolute sense. The correlation coefficient fixes that. You divide the covariance by the product of the two standard deviations. That division removes the units entirely. The result is a dimensionless number, the same regardless of whether you measured returns in percentages or decimals or dollars or basis points. And it always lands somewhere between -1 and +1. The fixed range is what makes correlation interpretable where raw covariance is not. The correlation between two variables A and B equals the covariance of A and B divided by the standard deviation of A times the standard deviation of B. Let's apply it to those same two equity holdings from the previous video. The covariance was 3% squared. For both of our holdings, the standard deviations are exactly 2%. So the correlation is 3 divided by 2 times 2, 3 divided by 4, which is 0.75. It's as simple as that to calculate the correlation. Now, what does 0.75 actually mean? Let's build up the interpretation from the endpoints first. Correlation of +1 means that the two variables move in perfect lockstep. Every time one deviates above its mean, the other deviates above its mean by a proportionally identical amount. No exceptions. In finance, a correlation of 1 between two assets means holding both gives you no diversification benefit. It's essentially the same position twice. A correlation of -1 means perfect inverse movement. When one goes up, the other goes down with perfect proportionality. If we had two assets with a correlation of -1, we could use them as hedges for one another, so that whenever one ends up going down, the other can protect you from the downside. A correlation of 0 means there's no linear relationship between the two variables. The deviations of one variable tell you nothing about what the deviations of the other variable are going to do. So 0.75 sits well above 0 and well below 1. These two holdings have a strong positive linear relationship. They tend to move together, but not perfectly. There are quarters where they diverge somewhat. In a portfolio context, that matters. Two assets with a high positive correlation tend to perform well or poorly in the same environments. Combining them does reduce some idiosyncratic risk, but because they co-move so strongly, they don't provide much protection against the conditions that hurt both of them simultaneously. Contrast that with two assets at 0 or negative correlation. A genuinely uncorrelated pairing means losses in one direction are not systematically accompanied by losses in the other. A negatively correlated pairing is more powerful still. Periods where one underperforms tend to be exactly the periods where the other outperforms. Now, the rational quant wants to correct a mistake that apparently showed up in Victor's last analysis. Victor had sent a note pointing out that two of his positions had been highly correlated over the past 6 months. He concluded that one was driving the other, that movements in position X were causing movements in position Y, and that understanding X would therefore let him predict Y. That reasoning is wrong, and it's wrong in a way that ends up being expensive if you act upon it. Here's a clean example of why. Cities with more fire stations tend to have more significant fire damage. If you ran a regression or a computerized correlation, you would find a positive relationship between the number of fire stations and the amount of fire damage within a city. By Victor's logic, you might conclude that the fire stations are causing the fires, that deploying more firefighters leads to more property damage. The actual explanation is a third variable, city size. Large cities have more fire stations because they need them. Large cities also experience more fire damage because there is simply more to burn. Both the fire stations and fire damage are driven by some underlying factor, and neither one of them is causing the other. That's what's called a spurious correlation, or more precisely, a case where a common cause produces a correlation between two outcomes that have no direct causal link. In finance, this pattern is everywhere. Two of Victor's positions might both move with interest rate changes or credit spreads, or with broad equity sentiment. If rates fall, position X rises, and if rates fall, position Y also rises. So x and y end up being correlated not because x moves y or y moves x, but because both respond to some underlying factor. So if you're watching x trying to figure out what's going to happen with y, it would be a much more direct step to just figure out what's happening with interest rates that's causing both of these things to change instead. High correlation between two variables tells you they move together. It does not tell you why. It does not establish which variable, if either, is doing the driving. And it does not let you rule out the possibility that both variables are being driven by something you haven't measured. This matters for investing in a practical way. If Victor believes one position drives the other, he might hedge the relationship incorrectly, reducing the wrong exposure or building a model that falls apart the moment the common driver shifts. The correct question is always, what are both of these things responding to? Correlation is a starting point for that question, not an answer to it. Danny flips through the estate's brokerage statements. The counterparty labeled TRQ shows up across dozens of transactions over more than a decade. He pulls Victor's quarterly fund returns and the position sizes attributed to TRQ in those same quarters. He works through TRQ's correlation framework. The correlation is meaningfully negative. When Victor's fund was above its average return, TRQ's position sizes were smaller. When Victor's fund was below its average, TRQ's positions are larger. He sits with that for a moment. Then he notices something in the margins. Victor had underlined the entire causation section of the letter. The letter appeared to be an attempt by the rational quant to convince Victor that his fund's losses were not related to the rational quant's fund's gains. And in the margin, Victor had written only one word: disagree. It appears that Victor had seen the correlation between his fund and the rational quant's fund's activities, and realized that something fishy was going on. While correlation doesn't imply causation, it also doesn't mean that causation isn't a possibility. So that's the correlation coefficient and the distinction between correlation and causation. Correlation standardizes the covariance by dividing by both standard deviations, which removes the units and produces a number that always falls between -1 and +1. Values near +1 indicate a strong positive co-movement, while values near -1 indicate strong inverse movement. Values near 0 indicate little or no linear relationship, and from a portfolio perspective, lower correlation between assets is what gives diversification its risk-reducing power. But correlation, however strong, never tells you that one variable is causing another. Two variables can end up highly correlated simply because both are responding to a common driver that you haven't directly observed. That distinction between correlation as a mathematical fact and causation as a causal claim ends up being one of the most important things to hold on to throughout the rest of this course.